All right, folks. I'm back. Been a couple days. Sorry. Had to go golf tournament and stuff. It's been tough.
He misses us, though.
I miss you guys. I'm back. I love you. And I'm sure you guys love me as well. Hey, lesson 110. It's basically an operations. So are we going to add, subtract, multiply, or divide numbers in scientific notation? We're going to make this real easy because ultimately all you got to do is type things into a calculator correctly and press enter. That's it.
Huh?
That's it. You have to know, should we add, subtract, multiply, or divide?
That's right.
If you know that, just type it in, press enter.
The calculator will do the rest.
Press enter. So here we go. Okay, operations, scientific notation. Whoops. Example 1.
How does using scientific notation help when computing with very large or very small numbers? Think about this question during the lesson.
Dang.
This graphic shows the relative size of the Earth and Moon. Here is the approximate mass of Earth and the approximate mass of the Moon. How much greater is the mass of Earth than that of the Moon? What does the exponent tell you about the magnitude of the number?
So, folks, when you look at the exponent and you compare the exponents of the Earth and of the Moon, okay, obviously the larger the exponent, what is that going to tell you about Earth compared to the Moon? A lot bigger, okay? And in fact, if it's two exponents higher, basically that's saying it's 2 powers of 10 bigger. 2 powers of 10. 10 times 10. So basically, Earth is going to be maybe somewhere around 100 times bigger than the Moon. Somewhere around there.
You can immediately compare sizes of two numbers by comparing the exponents. Although 7 and 35 hundredths is greater than 5 and 97 hundredths, the exponent in Earth's mass, 24, is greater than the exponent in the Moon's mass, which is 22. This shows that Earth's mass is the greater number.
Yeah. You want to do the activity? I don't think so.
They got this.
One way to solve the problem is to write the two numbers in standard form and subtract.
Now, writing in standard form, remember, that goes back to the bunny hops. That's going to take this first factor here and bunny hop to the right 24 times and filling in all the blank spaces with zeros. So this is going to be a 5, a 9, a 7, followed by 22 zeros. Okay, this over here would be a 7, a 3, and a 5, followed by 20 zeros. So very, very, very large numbers. Standard form, I don't think we want to do it this
Go
way.
write those out for us?
I don't think you want to do it this way.
5 and 97 hundredths times 10 to the 24th power,
I don't
when
think
written
so.
in standard form,
Oh, yeah.
Yes.
looks like this. That's a lot of
Ridiculous.
numbers.
That's a lot of
And
numbers.
7 and 35 hundredths times 10 to the 22nd power is written like this in standard form. Now, subtract. The difference is about 5.8965 times 10 to the 24th power.
That's great.
What is the disadvantage of using standard form to subtract these two numbers?
Well, people like me would maybe forget a zero. People like Mr. Fricky probably have no problems with it. But obviously, folks, when you have large numbers like this written out in standard form, it tends to lead to some mistakes sometimes.
The numbers have lots of zeros, which take time to write and are difficult to keep track of. Another way is to write the two numbers with the same power of 10. Notice that we can use a property of exponents to write 10 to the 24th power as 10 squared times 10 to the 22nd
Looks
power.
like product rule.
we can rewrite the number 5 and 97 hundredths times 10 to the 24th power to 597 times 10 to the 22nd power. Now, subtract the two numbers. We don't know what the next two digits of this number are. We can assume they are zeros, and our answer will be reasonably accurate. The difference is the quantity 597 minus 7 and 35 hundredths times 10 to the 22nd power, or 589 and 65 hundredths times 10 to the 22nd power.
Now remember, we said we're going to make this a lot easier. All you're going to have to be able to do is not any of this stuff. Just type it in the calculator right, press enter.
The last step is to convert the difference to scientific notation. Remember, the first factor must be greater than 1 and less than 10. The difference is about 5.8965 times 10 to the 24th power. Now you know how to add or subtract two numbers written in scientific notation.
All right, so if we go to the try it section, folks, now we're talking about Venus and we're talking about planet Mars. This is awesome.
The planet Venus is on average 2 and 5/10 times 10 to the 7th power kilometers from Earth. The planet Mars is on average 2 and 25 hundredths times 10 to the 8th power kilometers from Earth. What is the average distance from Venus to Mars?
I don't know. Okay, so folks, here's what I need you to do. I need you to take this stuff that's in your book and we're going to put the big old kibosh to it. Okay? We're not using those lovely little boxes. Okay, so put the kibosh to that. Let's go back up to this question, maybe. Okay, and we got to figure out the average distance. Miss Fricky, can you help me out on this? What do you think we're going to do? We're going to add, subtract, multiply, or divide?
Should we add?
I think so. I don't know. What do you think?
Come on, people, answer. What's your guess?
I think we need to add.
Okay.
Hey, so folks, all we're got to do, hey, first off, once we figure out, do we add, subtract, multiply, or divide? All we got to do, take the two numbers. If we have to add, take the two values in scientific notation. Type them into the calculator. Make sure you are putting them in parentheses. Okay, the parentheses buttons are right above, I think, the 7 and 8, the 9 on your calculator. Make sure you do this. Okay? You then hit the addition sign. Then, again, in parentheses, you type in the other value. Once you do that, you press enter. That's it. Questions? Mr. Friggy, I know you can do this in your head. Hey, if we add these together, what does that value come out to be?
Are you ready for it?
I'm ready.
2.5
2.5
times 10
times 10
to the 8th power.
to the 8th power, folks. Okay, so the average distance from Venus to Mars in scientific notation here, if we wanted it to change that into standard form, that would be 8 bunny hops to the right. Okay, now Mr. Fricky talked about just adding a whole bunch of zeros and then bunny hopping.
Yeah.
1, 2, 3, 4, 5, 6, 7. I'm going to add 7. Why? Because I know that's how many we need. Because we got to bunny hop 8 places. 1, 2, 3, 4, 5, 6, 7, 8. There you go. So how many miles in standard form? It looks to be about 250 million miles. Okay?
Big
So
number.
Example 1, that is a big number. That's why we write them in scientific notation.
Oh, okay.
Okay? Example 2. We read it. I'm not going to read it. This lady's going to read it.
The Confederation Bridge connects New Brunswick to Prince Edward Island.
Okay.
The main part of the bridge rests on piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation.
Okay, so folks, once again, when we read questions, when we hear questions, we got to think, do we add, subtract, multiply, or divide? So this is the distance between one pier. Okay? We want to know what is the total distance of 43 of them. We're
What
going to
operation?
add, subtract, multiply, or divide. I know the distance between one. I need to know the distance of 43 of those.
Can we just keep adding it up 43 times?
Ooh, do you want to do that?
I don't know. Do you know a better way?
Yeah, because if you're adding the same thing together 43 times, why don't we just take it and multiply by 43?
Oh.
So, folks, what we got to do, okay? Just take this value once again, number in scientific notation, put it in parentheses in your calculator or Desmos or whatever you're using.
Calculating device.
Calculating device. You put it in parentheses and you take and you multiply it by 43. You then press enter and it's going to kick out a value and that's your answer. That's it.
Yep.
That's it. So if we look at value here, they'll give us a value. You should come out to be 3.56 times 10 to the fourth power.
Bam.
Questions?
Do they need to have their calculator in scientific mode when they're doing this?
Yeah, and that's something we'll talk about in class.
Okay.
But a lot of times, if it's too large of a number, the calculator is going to kind of default to display it that way anyways. But we'll talk about how to change it to scientific mode. Okay, example number 3. I wonder what we're going to do. Oh, yes, we got to talk about a queen ant laying a whole bunch of eggs. Whole bunch.
A queen ant lays 1 83/100 times 10 to the 6th power eggs over a period of 30 days. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? Express your answer in scientific notation.
So, once again, when we read, we got to understand the information. We know this is how many eggs she lays in 30 days. The question's asking how much in one day. Last year, you guys in 7th grade with Mr. Stair, Mr. Treen, you guys calculated what are called unit rates. Okay, so if you know how much is in 30 days, you should know how to figure out in one day. Add, subtract, multiply, or divide. Starts with a D. It ends with divide. We got to divide here, folks. Okay? So basically, once again, all we do, take this, put it in parentheses, hit the divide button, hit 30, and then press enter. And then press enter. Okay, once again, it asks you to express your answer in scientific notation. We'll talk about how to change calculator to scientific notation. But if we look at their work, final answer, would come out to be 6.1 times 10 to the fourth power. Now, folks, just to put that into standard form, this queen ant, busy lady. Okay, 6.1 times 10 to the fourth power in standard form. That's a 6 and a 1. We got a bunny hop 4 times, which would be 3 more zeros. My lord, folks, that queen ant is laying 61,000 eggs every day. That's pretty impressive.
That's your unit rate right there.
Okay.
61,000 per day.
61,000 eggs in
Good for
one
her.
day. That's a whole lot of ants, folks. Little baby ants. Okay, folks, so that wraps up the 3 examples for this lesson.
You want to do the drive for this one?
Operations. Oh, wait a second.
The fun's not over.
My bad. That's my bad. All right, so You don't want to hear me read. Let's listen to this person.
There are
read.
1 times 10 to the 14th power good bacteria in the human body.
Good
There
bacteria.
are 2 and 6 tenths times 10 to the 18th power good bacteria among the spectators in a soccer stadium. About how many spectators are in the stadium? Express your answer in scientific notation.
Well, folks, this is the total amount of good bacteria in the entire stadium. This is how much is in one person. Are we going to add, subtract, multiply, or divide to figure out the number of people? This is total. This is how much is in one.
Adam.
No,
Multiply.
no,
Subtract.
and
What? I give up.
we're going to divide. Folks, we're going to divide. This is the total. This is how much in one person. Okay, so we need to take and put them in
Parentheses.
parentheses. 2.6 times 10 to the 18th power. Put it in parentheses. Okay, then you're going to hit the divide button. And you're going to put 1 times 10 to the 14th power. And then you press enter. Okay? Mr. Briggy, I know you're a computing genius. What does this come out to be?
Comes out to be a number.
A big number.
Would you like to know that number?
Yeah. It's probably not too big because we're talking about spectators in a stadium. The biggest stadium I know is, right around 100,000 people or so. But
2.6
this comes out to be 2.6
times 10 to the 4th.
times 10 to the 4th power. Okay? In scientific notation, first factor between 1 and 10. Second factor is a power of 10. There you go. Scientific notation. Standard form, just for fun, to think about what this number represents, would be a 2 and a 6, followed by 4 bunny hops, or 3 zeros in this
3
case. So
26,000
there's
people.
26,000 people in that stadium. Now that wraps up the 3 examples for lesson 110. That's all we got. See you soon.